Welcome to the fourth installment of the Reservoir Sedimentation Management series. These webinars are sponsored by the Cooperative Institute for Research in Environmental Sciences at the University of Colorado Boulder in partnership with NOAA. Today's talk will be on permitting for reservoir sediment management, given by Dr. Rollin Hotchkiss, who is a professor and chair of the Civil and Environmental Engineering Department at Brigham Young University. Also giving the talk will be David Olson, who is a regulatory program manager at the headquarters office of the U.S. Army Corps of Engineers, where he manages the Corps Nationwide Permit Program and Endangered Species Act compliance for Department of the Army permits.
Today we'll be talking about the following items. Here's kind of a roadmap. I'll be handling the introduction. David will then talk about the next two items, and I'll finish up on the following three. I'm going to give you a general overview of how dams have been designed in the United States. This is a generalization. There are exceptions. But decades ago, many decades ago, this is how you build a dam. You start by estimating how much sediment might come into a reservoir during the economic design life, usually about 50 years or so. You conceptually place that incoming sediment volume on the bottom of the reservoir, and then you place your lowest level outlet above that stored volume. What you've done then is you've provided an area for the sediment to deposit in the reservoir. It's an area called dead storage. This means that most of the incoming sediment is likely to drop out in the reservoir. Now, this design procedure, decades old, was imported by other countries around the world. But we're lucky here in the United States that many of our dams, most of our dams, have had relatively low sediment inflow. That's not the case abroad. For example, the Sanmenxia Dam on the Yellow River in China, the Aguacate Dam in the Dominican Republic at the confluence of two rivers there in the Dominican Republic, the Nisao and Maumita, and the Geberem Dam in Switzerland on the Massa River. All of these rivers carry very high sediment loads. And so the design procedure of essentially trapping the sediment for the economic design life would not work there. So sediment management has been developed abroad. And previous webinars have gone over the various ways of moving sediment downstream in some detail. These are summarized on this slide. So the procedure for designing dams was imported by other countries, and they've modified that in order to move sediment downstream. In the meantime, back here in the United States, our reservoirs continue to fill with sediment, and storage capacity in the US has been declining since about the year 2000 due to reservoir sedimentation. So what do we do? Well, we would like to do the same kind of management techniques as have been developed elsewhere. But it's been interesting because in this interim period, a number of decades, something happened here in the meantime, and that is that we passed landmark environmental legislation. And that legislation is, the purpose is to preserve the quality of our waters in the United States. At the time these regulations were adopted, there really wasn't a need to move sediment downstream into a receiving river from the reservoir itself. And I'd just like to remind all of us that dredging deposited sediments from a reservoir and storing them somewhere in the watershed is just not a viable long-term option. So the question is then, how can we begin to manage our sediment at reservoirs by using various techniques to move that sediment downstream? So now I'm going to ask David to talk about the development of this environmental legislation, and then talk to us about the core procedures. David?
Thank you very much, Rollin. How's the audio? All right. So I'd like to give an overview of some of the environmental laws that may apply to reservoir sediment management activities. The earliest law under which the Corps regulates activities is the Rivers and Harbors Act of 1899. And under this law, the Corps regulates structures and other work in navigable waters. In other words, waters that are used as highways to transport commerce between states and foreign countries. After the Rivers and Harbors Act, Congress passed another law called the Fish and Wildlife Coordination Act back in 1934. And under the Fish and Wildlife Coordination Act, before the Corps does any project that alters water resources or permits a project that would alter water resources, the Corps is required to consult with the Fish and Wildlife Service and now also the National Marine Fisheries Service to seek their input on potential ways to mitigate impacts to fish and wildlife before those projects are constructed to minimize those impacts. The Wild and Scenic Rivers Act was passed by Congress in 1968 to protect wild and scenic rivers that have high environmental value and scenic value. And then sort of the landmark legislation happened in 1969 with the passage of the National Environmental Policy Act, which is a procedural act that requires that the Corps and other federal agencies, before they do their actions that might affect the human environment, that they make sure that they have good information from which to make sound decisions. And the National Environmental Policy Act also has a public process with that to help both the federal decision makers and the public better understand these projects and can provide meaningful input to help protect various components of the environment that benefit society. In 1972, Clean Water Act sections 401 and 404 were passed by Congress. Under section 401, the states make sure that federal permits issued under section 404 comply with their water quality standards, and we'll get into more detail on what these two sections of the Clean Water Act require. And then finally, there's the Endangered Species Act of 1973, which protects species and helps, tries to prevent them from going extinct. Next slide, please. So first, I'd like to discuss the National Environmental Policy Act. So it's our basic national law for protection of the environment. And its main goal is to ensure that information is available to the public, officials, and citizens before those officials make decisions on activities that would affect the environment. So the goal is to produce better decisions, not generate a bunch of additional paperwork. So under National Environmental Policy Act, we strive to have meaningful documents that help explain what the proposed action is and what the potential environmental consequences of that action are. Now, to produce these documents, there are some levels, some thresholds, and the thresholds will dictate how much detail and how comprehensive these NEPA documents need to be. So the most comprehensive NEPA document is called an environmental impact statement, and that's required to be prepared for any federal action that would have a significant impact on the human environment. For those federal actions that will not have a significant impact on the human environment, the National Environmental Policy Act requires the preparation of an environmental assessment, which is you could say it's a kind of a brief version of that environmental impact statement. The content in general would be roughly the same, but it would be at a lower level of detail and analysis. And then under the National Environmental Policy Act, agencies can also develop what are called categorical exclusions, which they're for generally very minor activities, and they would never reach the potential of significance in terms of impact on the human environment. But they're a tool to help reduce paperwork in where these more comprehensive NEPA documents are not needed. Next slide, please. The Federal Endangered Species Act requires that federal agencies consult with the U.S. Fish and Wildlife Service and the National Marine Fisheries Service to ensure that their actions are not likely to jeopardize the continued existence of any endangered or threatened species or result in the destruction or adverse modification of those species. Now, which agency that the Corps would consult with before it made a decision on a permit to do reservoir sediment management activities depends on which species may be involved. So if they may affect salmon that migrate from the rivers to the oceans and back, then we would consult with the National Marine Fisheries Service. If it may affect some inland species, we would consult with the Fish and Wildlife Service. In a lot of cases, we end up consulting with both services. Now, these consultations can happen in a number of different forms, depending on their severity of potential effects to listed species. Formal consultation is required for any activity that may affect and is likely to adversely affect any listed species or critical habitat. If the proposed activity has been minimized so that it would not have any adverse effects on those listed species or critical habitat, then we can do a process called informal consultation. And in many Corps districts across the country, they had developed programmatic consultations with the Fish and Wildlife Service or National Marine Fisheries Service to help streamline that Endangered Species Act compliance process. So in other words, if a proposed activity meets the terms of a programmatic consultation, then an individual consultation is not required for that activity. Next slide, please. The Clean Water Act was passed in 1972 with the objective of restoring and maintaining the physical, chemical, and biological integrity of our nation's waters. It's made a huge difference in the quality of those waters over time. However, that law, when Congress wrote it, they didn't really think about reservoir sediment management activities. There weren't that many reservoirs at the time that may have been impacted by this law, but as time has gone on, the importance of the Clean Water Act and reservoir sediment management activities has grown. Next slide, please. So the Corps has some program authorities, Section 10 of the Rivers and Harbors Act of 1899, which I mentioned briefly, Section 404 of the Clean Water Act. We've also issued a guidance letter to our field staff called Regulatory Guidance Letter 0504, in which we spell out the conditions under which a discharge of sediment from a reservoir would trigger a permit requirement under Section 404 of the Clean Water Act. I would also like to talk about some of the types of permits that we issued, and also the environmental criteria that we use to determine whether a permit should be issued under the Clean Water Act, which is Section 4.4b. Next slide, please. So our three main statutory authorities that the Corps regulatory program operates under are Section 10 of the Rivers and Harbors Act of 1899, in which we regulate the construction and dredging in navigable waters, those highways of commerce that transport goods and services between the states and to foreign countries. Section 404 of the Clean Water Act, we regulate what are called discharges of dredge or fill material into waters or wetlands, and I'll explain in more detail what those are. And then one authority that we have that we don't necessarily apply to reservoir sediment management activities, it's more of a coastal authority, is Section 103 of the Marine Protection Research and Sanctuaries Act, in which we authorize the transport of dredge material for ocean disposal. Next slide, please. So under Section 10 of the Rivers and Harbors Act of 1899, we regulate activities that alter or modify the course, condition, location, or capacity of navigable waters of the United States. And these waters are generally defined as tidal waters. They're subject to the ebb and flow of the tide. Or in inland waters, those are waters that have been used, could be used, have been used in the past, or may be susceptible for use to transport interstate or foreign commerce. Next slide, please. Under Section 404 of the Clean Water Act, we regulate discharges of dredge or fill material in the waters of the United States, and we define discharge of dredge material as any addition of dredge material into, including redeposit of dredge material other than incidental fallback within the waters of the United States. Incidental fallback is a term that has been subject to a lot of litigation, but I'll just characterize it as something more than a de minimis discharge. It could be sediment dripping off a bucket of a clamshell dredge, something very small. On the other hand, a discharge of fill material is an addition of fill material into jurisdictional waters and wetlands that has the effect of either replacing any portion of that water with dry land. In other words, filling a wetland to make it higher so that someone can build a house on it, or changing the bottom elevation of any portion of waters in the United States. And this could be in terms of what might be regulated by the Corps for reservoir sediment management activities, discharging sediment from a reservoir and having that sediment accumulate a little bit downstream, but it does raise that bottom elevation to a discernible degree. Next slide, please. So getting to more precisely what Section 404 and how it relates to reservoir sediment management activities, in 2005, the Corps issued Regulatory Guidance Letter 0504. And what regulatory guidance letters are is that they help explain how to apply our regulations in a more precise manner through guidance rather than going through an additional rulemaking process. But what we do is we hope that this provides both our staff in our district offices and also the regulated public with more clarity about what the Corps regulates and what we don't regulate. But this regulatory guidance letter applies to both of our statutory authorities, Section 10 of the Rivers and Harbors Act and Section 440 of the Clean Water Act. And that regulatory guidance letter is available at this link on the Corps' webpage. And it also states that Corps permits are not required for routine high water flow dam operations that pass sediment-laden water from or through the dam. In other words, any normal dam operation doesn't trigger that 404 permit requirement or that Section 10 permit requirement. But however, if there is a deviation from those normal operations, they may require a permit depending on what's being done and its effects on the environment in terms of what's happening to that sediment. Next slide, please. So the regulatory guidance letter states that for the discharges that are regulated under Section 404 could be the sluicing of sediments in a manner consistent with hydraulic dredging, and we would consider this a discharge of dredged material. And if the discharges of sediment from the dam would raise the bottom elevation of downstream waters to a discernible substantial degree, then we would consider that a discharge of fill material. And then both those types of activities would require a Section 404 permit. However, the regulatory guidance letter makes it clear that if there's de minimis discharges due to normal dam operations, those don't require a Section 404 permit. And if we're in navigable waters and those management activities would alter the course, condition, or capacity of navigable waters downstream, then that would also trigger a Section 10 requirement. Next slide, please. So some examples of discharges that would require permits under those authorities: opening the bottom gates of the dam, dam breaching, or dam removal activities. Those would result in a fair amount of sediment being discharged downstream and thus trigger the 404 permit requirement. Next slide, please. So a brief explanation of how the Corps is organized, and if you are interested in applying for permits for these activities, to whom you should go. The Corps is a highly decentralized organization. We have 38 Corps districts across the country that implement our permit program, and they have substantial discretion in how they implement that program, but they are being consistent with the national rules and policies that we establish here at Corps headquarters. So if you're interested in doing these activities and applying for a permit, I strongly recommend that you reach out to them and talk about the project and ask them what they would require for these permit applications. Next slide, please. So the Corps issues two types of permits. One is called an individual permit, and these are what would normally apply to reservoir sediment management activities. An individual permit authorizes a specific activity. We are required through our regulations to issue a public notice to solicit comment from the public and other agencies on the proposed work. That public notice is usually 30 days. And after the Corps district receives those comments, then we would evaluate the comments and then start preparing a permit decision, whether that would be to issue the permit or to deny the permit. And part of that decision documentation is doing a public interest review, which I'll describe a little bit later on. a 404B1 guidelines analysis if a Section 404 permit is required, and some type of other decision document, whether that to comply with the National Environmental Policy Act, whether that's an environmental assessment or an environmental impact statement. We do have another category of general permits, and these only authorize activities that are similar in nature and have only minimal individual and cumulative adverse effects. In other words, very small impacts on the environment, minor impacts. We have what's called a nationwide general permit, which is issued by Corps headquarters. And we also have our districts with the authority to issue regional general permits if they have a category of activities in their particular region that warrants a general permit authorization. However, most reservoir sediment management activities would not qualify for any of our existing general permits, so we'd be focusing on the individual permit process. Next slide, please. So for that individual permit process, the project proponent would submit a permit application to the Corps district. The district would issue the public notice for a 30-day period, usually, to solicit comment on that proposed work. They would also evaluate the proposal to see whether it might affect any listed species under the Endangered Species Act. And if it does, then they would initiate consultation with the Fish and Wildlife Service or National Marine Fisheries Service as appropriate. The Corps district staff would next evaluate the comments it received in response to that public notice and prepare its decision document. And then the district engineer would make the permit decision. Now, in all of our Corps districts have usually a colonel that's from the Army that manages the district, but most of the permit decisions are made by our regulatory office, and those permits decisions are delegated down. So if you're working on a permit application with the district, then you're most likely just talking to the regulatory staff who will make the decision, and then it's always best to try to work things out with the staff as that process goes along. The district commanders only really get involved in certain circumstances, so it's always best to work with the staff. Next slide, please. So for the National Environmental Policy Act process for Corps permits is that initial determination whether the activity would require an environmental impact statement if it's significant impacts, environmental assessment for anything less than significant impacts, and then there's these potential categorical exclusions, but there aren't really any categorical exclusions that would apply to reservoir sediment management activities. So most circumstances we'll be looking at environmental assessments. We would do any necessary consultations we do during the permit process would be documented in these NEPA documents. So we would evaluate those comments in that NEPA document. And then if we make that finding of no significant impact, then we would conclude the process with an environmental assessment. One way that we differ from our civil works programs is that the regulatory program does not circulate its draft environmental assessments for public comment. We generally prepare them at the end of the process, just before we're ready to make our decision. So in other words, the public and the agencies really don't get a second bite at the apple during this process. Next slide, please. So the public interest review applies to all our permits. So basically we look at 21 factors and do a weighing and balancing process to see whether or not generally that the project is not contrary to the public interest. So we would look at any of these factors, determine whether they're relevant and what the impacts are, and then after that weighing and balancing, we would decide whether the activity is not contrary to public interest and therefore would warrant receiving a permit. Next slide, please. The 404 guidelines applied only to activities that require Section 404 authorization under the Clean Water Act. The guidelines were issued by the U.S. Environmental Protection Agency, and they're the substantive criteria for evaluating the effects of discharges of dredged or fill material on the aquatic environment. There are several subparts to this regulation. Subpart C focuses on impacts to physical and chemical characteristics of the aquatic environment. Subpart D focuses on biological characteristics of the aquatic environment. Subpart E looks at what are called special aquatic sites, and examples of special aquatic sites are wetlands and riffle and pool complexes and streams, but they are designated by EPA as having a higher value than other types of waters, and so forth. That's how they become special aquatic sites. Subpart F also requires looking at uses of impacts to human use characteristics of the aquatic environment. And through the 404B1 guidelines, the Corps is required to evaluate various alternatives to the proposed work and decide which of those alternatives is the least environmentally damaging practical alternative that's necessary to achieve that overall project purpose. So in other words, when you have an idea of what you want your project to do, what the Corps requires is an examination of alternatives that can achieve that project intent, but has the least amount of impact on the environment. Next slide, please. And here we'll transition over to Rollin, who will talk about Section 4.1 of the Clean Water Act.
Thank you, David, for that explanation. As you read the contents of this slide, I'd like to review what we're talking about. That is managing reservoir sedimentation using the techniques and alternatives that have been defined in prior webinars. And essentially, it means passing sediment downstream to the receiving river. Section 401 of the Clean Water Act comes into play here. And this is authority granted to the states by Congress. What's challenging about this is that the Clean Water Act was written for clean water. And states typically have pretty low limits on nephelometric turbidity units. That is how turbid water can be. The Clean Water Act was written with controlling erosion from construction sites in mind. It was not really written in terms of moving sediment downstream from a dam. So it's a little challenging when you approach a state and say, that's what I want to do. For example, the photograph at the bottom of this slide shows a former graduate student of mine standing in Ferron Creek in central Utah. And that's during or after a summer thunderstorm event. He's holding up a water sample. He's standing in the river. And you can judge what NTU limit that might be. Most states would like an NTU limit of about 10. But the sediment concentration of waters going into reservoirs can exceed that by a couple of orders of magnitude pretty easily. For example, here in the state of Utah, sediment concentration in the discharge shall not exceed 0.1 kilograms per meter cubed. I've done a little bit of units conversion there. In the creek pictured in the previous slide, the mean daily sediment concentration is a lot more than that. And the maximum daily concentration, not instantaneous, but daily, is 500 times higher. That's the sediment coming into a reservoir. So now I'm going to be talking about my own experience for the next several slides here. As David explained, the applicable regulatory letter, Section 401 and Section 404, I found that there is some ambiguity in how that's interpreted. And that's primarily due to the fact that we haven't done this very often in the United States. You're very likely to require a 404 permit if you would like to move sediment downstream from a dam. Unless that's been done routinely on an annual basis, for example, you're going to require a 404, and it's likely to get a little bit complicated and a little bit confusing for everybody. So I'd like to move into a case study at Millsite Dam in Ferron, Utah. The topics I'll cover in this short case study are shown here on the slide. Millsite Dam was closed in 1971 as part of the original Soil Conservation Service Public Law 95 dams constructed in the United States. About 18,000 acre-feet originally, it's lost some capacity. And it's been turned over to a local irrigation district who guards very jealously the active storage in that reservoir. It's used primarily for irrigation, water supply, and recreation, primarily irrigation though. The setting, an aerial view from Google Earth. You can see that it's in a very arid area. The soils there are highly erodible. You can see a sediment plume going into the reservoir, and the upper one half of the reservoir has a lot of sediment there. The gradation is from cobbles to very coarse silt. The dam itself releases water in the summertime through a 54-inch low-level outlet. This clear water, no sediment in it, feeds 3 irrigation canals. Now, we might think that would be an ideal place to release sediment downstream, but if that were the case, then it would get into the irrigation canals and clog up the irrigation equipment. This is the primary outlet at Millsite Dam. There is also an uncontrolled spillway that spills 5 out of 7 years on average. When the reservoir fills sufficiently high, the water simply goes over the spillway. That water is clear because the sediment has already dropped out. The question is, when does the sediment come into this reservoir? Shown on the x-axis is a 12-month period beginning in January and ending on the right in December. And on the y-axis are 2 values. One is mean daily discharge in what appears to me to be dark blue. And the other is mean daily suspended sediment in tons per day divided by 10. This is a snowmelt dominated watershed, and most of the sediment comes in during a particularly short period of the year. So as a matter of fact, 90% of the annual load comes in during 6 weeks. And that coincides when the water is spilling over the spillway if the reservoir level gets high enough. And on a daily basis, they lose about 0.2 of an acre foot of storage due to sedimentation. So how to manage reservoir sediment at Millsite Dam? The idea was to bring in a commercial dredger at the indicated cost to dredge sediment when that spillway is moving clear water downstream. By doing so, I calculated that they could move between 20 and 40 acre feet of sediment per month, and that would require the entire spillway discharge period. Now, as people get more experience with the dredger, they may shorten that time, but it could only occur if and when the spillway is discharging. How about a permit? In the early goings here, it was not apparent that a 404 might be required. I contacted the Utah Department of Environmental Quality, and they said, go ahead and do that. Of course, we needed to talk about the fact that I'm going to be violating those effluent standards. But once they understood that we were trying to restore a sediment balance across the dam and not recover storage, but maintain reservoir storage, they could see some real benefits, particularly to the downstream environment where native Utah fishes require turbidity in order to hide from predators. So they were on board and issued an initial permit. But then a colleague of mine at the Utah Division of Water Resources suggested I might check to see if we need a 404, and of course I did. That's because they had not dredged or removed sediment from the reservoir before, and it constituted a deviation from the norm. Also, people are pretty nervous about introducing sediment to a river. So after the first 6 months, the 404 was stalled, and I'm sharing these slides to share the experience. The people that I was working with out of the Sacramento district are top-notch. They're very good, and we had a good working relationship. We were working through this together. So the irrigation company was a little frustrated at the time. My initial application was denied. So these are a list of agencies that were involved, and David explained earlier about the Endangered Species Act and others that come into play. And all of these agencies were involved. The Corps coordinated the activities of these folks. So more additional requirements were made, including how much deposition might occur downstream if we were to introduce sediment to the downstream channel. And could we match the grain size distribution of the sediments coming in? The State Department of Water Quality was very interested in matching that. And I explained that we would not be able to move coarse cobbles downstream from the dam. I would be providing turbidity downstream, but not that coarse bed load movement. After 1.5 years, we were still a little bit stalled, kind of an iterative process going back and forth. Everybody was a little bit unsure of what exactly should be required in the permit. After 2 years, though, a permit was issued. It was interesting that there were no public objections. Not one comment was received from the public. The Corps had not seen an application on this scale before. As a hydraulic engineer, I had the option of doing simple or complicated hydraulic calculations. I opted to try to keep them simple, and that was acceptable. The state of Utah was concerned about being very rigorous in their review. They had had a few permits that had caused some trouble for them. We also received a lot of help from the state. Part of our permit was to field sample for macroinvertebrates, and they helped us set that up. This is my monitoring program. If you look at this, on the left is the dam. This is Ferron Creek, about a 10-mile reach. Cross sections were established at each of these marked areas. And I surveyed before and after each dredging operation to see if there was any deposition. In 2015, we were able to dredge for the first time, but at the time, the spillway was almost done discharging. Here's what it looked like. You can see two colors of water going over the spillway. On the left side of the spillway is the clear water that's coming from the lake. On the right side is where we've added dredged sediment material to the discharge. This then goes on downstream where we monitor for turbidity, dissolved oxygen, water temperature. Here's what the story looks like. On the x-axis, we begin April 16th in 2015 and go to July, about 3 months. On the y-axis is discharge. The blue is inflowing water, and the red is outflowing water. So the reservoir filled about here and began to spill. During that time, we were waiting for the permit. We got the permit on the 15th of June, and we were able to remove sediment. Now, these black lines represent a mass curve of sediment. This is how much is coming into the reservoir, and this is how much we removed. Based on that 2 days experience, we requested an amendment to the operations that we might be able to get more sediment out of the reservoir. We realized that by the time the reservoir fills with water, most of the sediment had already come in. So our operation was amended to use the average incoming sediment concentration. What that means is that our outflow could be higher, have a higher effluent. The approval process went very quickly, rather smoothly. We were ready for the next year, but there was very little discharge. 2017 was better. Here's a story from 2017. This is about a 2-month period. The blue is inflow, the red is outflow. So the spillway began discharging here. This is a graph of sediment concentration in milligrams per liter. The blue is the incoming sediment concentration, and the orange is the outgoing sediment concentration. It's apparent by the graph that we didn't get all of the sediment moving downstream. If we look at how much sediment came in during that 2-month period, the upstream, this is how much sediment came in during about 6 weeks, about 20 acre feet. This is how much we removed, about 2.5 acre feet by our dredging operation. Had we been able to dredge 24/7, we would have been able to remove 30 acre feet. And had we been able to dredge 12 hours continuously for that 6-week period, we would have been able to remove the incoming sediment. Was there any deposition downstream? Let's take a look at the Rollin cross-section. Here we have a post-dredge, pre-dredge, post-dredge. There was no deposition. So why was it so difficult to obtain this permit? Everybody agreed that this was a good idea to maintain storage capacity, to restore turbidity downstream. It was, though, the first time of an operation of this size, and lots of folks are watching. Also, it didn't help that I was a beginner at this and had to learn the process as I went along. So a couple of challenges that we face. What is baseline conditions? What needs to be preserved in the field? A channel, after all, may in size after a dam is constructed. The 2-year flood, for example, on Ferron Creek is well within the banks. What about deposition? Is that going to be allowed or not allowed at all? Also, reaches downstream from a dam adjust, and after 50 or more years, a new ecosystem has been developed and perhaps has reached equilibrium. If we reintroduce sediment downstream to restore a sediment balance across the dam, that probably will upset the ecosystem. So is that going to be allowed? So to finish up our webinar presentation today, and David and I are working on some projects right now. We realize that we all need more education on the permitting and legal aspects of reservoir sediment management. And we're having discussions with these agencies and hope to continue those. The subcommittee on sedimentation is also very helpful, as is this sponsoring organization of these webinars, NRSST. Finally, the Environmental Advisory Board of the Chief of the U.S. Army Corps of Engineers is involved. One of the tasks that we're working on is to see if any streamlining can occur in this process. Right now, we're collecting information from the districts in the Corps to see what their experience has been with issuing permits for reservoir sediment management. We hope to learn from that and hopefully come to perhaps a better understanding and more streamlined way of managing reservoir sedimentation. Thank you.
All right, thanks Rollin and Dave. So we have about 15 minutes left. If we could do a little Q&A, that would be great. Folks that have been on these webinars before know that you can just send questions to me anonymously if you want. So I'm the host, Toby Minear. If you want to send those over, then I can ask them. You can also just post them to the group and I can read them out if you don't want them to be anonymous. So I'll go ahead and send them over. So we have one here, Rollin, for you. Do you feel that statewide or regional sediment management programs, as is often done in coastal zones, help to address many of the large-scale sediment issues you encounter?
I think it could. Of course, there are differences, but they do occur over larger regions. For example, here in the arid West, we have very large reservoirs with carryover storage, often located in arid environments with relatively sparse populations compared to other parts of the country. And I think that we may be able to develop some regional management guidelines that could help out.
On a related note, Rollin, I know that when you get into some of the more developed watersheds, there are a number of dams in the same watershed, and I wonder, there must be some kind of coordination. You wouldn't want to remove sediment from one reservoir and then just have it pass to the next reservoir, and then essentially have everyone in the chain spending money to remove that sediment. I wonder, that kind of goes to Craig's question there, but I wonder if you have any thoughts about that.
It's difficult and complicated. We have an infrastructure now that's well developed in terms of constructed dams. And it's an obvious issue. If we were to pass sediment downstream from reservoir A and it goes into reservoir B, well, then you're just passing the problem downstream. And that's when watershed management comes into play. We really need to look at this at perhaps a watershed scale. I know the Kansas City District of the Corps is considering this in their series of dams and reservoirs in that state of Kansas. It's a complicated one for sure.
It seems like you'd want to have everyone pitch into a general fund to be able to cover that cost, rather than having the upstream water or the upstream dam covering all the costs. We have another question here. There have been several efforts in recent Water Resource Development Act bills to authorize the removal of sediments from flood control reservoirs in the West. Some of these sediments are marketed for construction projects. Do you have any perspective on permitting issues associated with this?
I don't. David?
Yes. In fact, the Corps issued about a month and a half ago a notice to solicit proposals to do some pilot projects on having these sediments moved from some of these reservoirs so they could be used for construction projects. And the proposals that we've received so far have been provided to the appropriate districts for evaluation, and then they'll pick some as part of this pilot project. Some of these won't require permits because they would be part of the federal flood control project, but we are also soliciting proposals for some activities that would require permitting. And I think, if the project would involve just dredging out the reservoir and moving that sediment to an upland site for use in construction, that's something that we permit fairly frequently. What's new and what we're trying to help educate our regulatory staff on is this approach of moving the sediment downstream and helping our district staff understand that this sediment, even though it's not the clear water most people would like to see, it's still important to move it downstream, and that these impacts can be managed and permitted. So that's something that we would like to, as Rollin mentioned, help educate the agencies on in the future to help the permitting go more smoothly.
I can add that I'm a member of the Environmental Advisory Board that works with the chief. And one of our tasks is to evaluate and kind of look over the shoulder of this activity that David just mentioned, and that is the beneficial use of inland sediment management. So we'll be following that closely in the next few years. Thank you.
Okay, another question here. Are or how are any potential effects of climate change considered in the regulatory agency viewpoints?
And if I may tackle that one, the Corps has some guidance for its civil works side on how to consider climate change in its projects. Regulatory does not. If we get comments in response to a public notice on potential climate change impacts, then we'll evaluate those in the perspective of what the proposed work is that we regulate. But we don't have any formal guidance, so it's kind of at the discretion of how our district staff would view it.
Okay, thanks, Dave. Here's another one. I'll try to paraphrase here. There was formerly a feasibility study done by Reclamation on the proposal of transporting fine sediment from Lake Powell downstream of Glen Canyon Dam for purposes of augmenting turbidity in the Colorado River to benefit conservation of listed humpback chub. Supposedly never implemented. the question is for the permitting possibilities and challenges involved when sediment management involves moving sediment from one state to another or others.
If I may, I'd probably have at least a partial response to that. So if the water would move between two different states or more states, then that's a situation where the U.S. Environmental Protection Agency would consult with the affected states and help them reach their water quality certification decision, because one state by itself cannot dictate for another state whether or not its water quality standards have been exceeded. So that would be a role for EPA to play in that 401 certification process.
Thank you, David, for that answer. It might be a good time to remind all of us that when a dam is constructed and built, the owner and operator is under no legal obligation to trap sediment. It was just a design philosophy taken decades ago. There was no legal requirement to trap sediment behind a dam. So it's perfectly legal if you build a dam to pass that sediment downstream from the first day and just leave it moving downstream.
I have a question here for either of you. In the slides, Dave, you'd mentioned that there's sort of a normal high flow period, which would be considered sort of typical operations. I wonder if you were a dam operator and you were to start operating a dam to pass through the entire incoming sediment load. Do you think, it would be a change from what had been done previously, but would that require additional permits?
If it was done during a storm event, and would be essentially, I think, considered a normal activity because one would expect that high flow to occur then I would say that probably wouldn't require a 404 permit. If it happened out, and we can consider seasonality as part of that normal operations. So if you're at a time of year where high flows are expected because that's when the rainy season happens, then that certainly can be weighed in as to whether a permit decision, a permit is required. So I think, we would look at that, what's normal over the course of the year. Thanks.
Yeah, thank you. Okay, it seems like the questions are slowing down here. So I think we'll just go ahead and call it there. Thanks very much, Rollin and Dave, for giving a great talk. That was right on, spot on. So thanks very much.
Thank you very much.
Thank you.
All right, take care, everyone.